summer months, if you look up on a clear night, well away from the lights of a city, you see a milky band of light, which is the Milky Way, our own galaxy. Some stars are all by their own, like our own sun. Others form in groups, in binaries, or in clusters. It's a very young cluster, newborn stars. This is a Pleiades, a naked eye star cluster, a young one, but still 100 million years old. And out of the disk of our Milky Way, there are things called globular clusters formed of stars which are typically over 10 billion years old. There's 100,000 stars in these clusters typically. So the Milky Way is a big, huge galaxy containing over 100 billion stars. So the sun is about 25,000 light years from the center, and it's about 100,000 light years across. If you want to know more, watch the Monty Python Galaxy song. If we now go on a journey down deep into the center of our Milky Way, we have to switch our view from the optical to infrared light, because there's dust which blots out our view in the visible. So the sun is orbiting our Milky Way. It takes a couple of 100 million years to go around. But right at the center, we would expect the gas and the stars to be at rest. But in fact, when we look with the sharpest view of the biggest telescopes, we find that things are in motion at the center of our Milky Way, whether it be gas clouds, which is circled in this image, or if we're looking over a series of images taken maybe over 10 or 15 years, if we look at individual stars and their motions, we see the ones right in the center are moving very quickly, which means there's something very massive and very faint, completely invisible, right at the center of Milky Way. And what we think is there is what's called a supermassive black hole, with a mass of a few million times that of our own sun. And we think all big galaxies like our Milky Way have big black holes at their centers. Beyond the Milky Way, if ever you find yourself in the southern hemisphere and you look up on a clear night, you might see, again in summertime in the southern hemisphere, patches of what looks like cloud. Those patches are galaxies, satellite galaxies of our own Milky Way. This is the larger of the two. They were named by Europeans after an explorer called Magellan, the large and small cloud. And the large cloud, even though it's a lot smaller than our Milky Way, it's got a huge stellar nursery, 100 times bigger than our own Orion Nebula. And deep in the center of this region called the Tarantula, there are the hottest, most massive stars that we know. The brightest, 10 million times brighter than our sun, which is also 100 million times heavier than the Earth. So these two galaxies, the small and large cloud of Magellan, are in orbit, extreme eccentric orbits around our Milky Way. Our sun lies within the disk of our Milky Way, and so we can't see our own galaxy from the outside. But this visualization tries to convey what it might be to be able to pass by the stars in our own disk of our Milky Way galaxy, passing by all these stars and nebulae, and to take a view from the outside at how it might look. Its structure is very much like a couple of fried eggs back to back, with a bulge in the middle. And what we found is when the stars and the gas are rotating, they're going faster than we expect them to do based on the amount of starlight that there is, the mass of stars. So something different called dark matter, we think, is the dominant source of mass in our Milky Way spiral galaxy and other galaxies. So if we go out from the Milky Way, past these two satellite galaxies, and then we turn our view to the other nearby big galaxies close to our Milky Way. So on the left, we have Andromeda, and on the right, this is Triangulum its satellite galaxy, its large satellite galaxy, a small spiral. Andromeda is a bit bigger than the Milky Way, with a couple 100 billion stars. Now, when we look at large distances, we find galaxies moving away from each other. But the Milky Way and Andromeda are quite close together. And what we find is that they're moving together so that in the future, they're going to crash into each other. So if that was a Milky Way, and we look over at Andromeda, they're coming together, not anytime soon, don't worry, in many billions of years' time. But in a few billion years' time, we'll find our two galaxies, these two big spiral galaxies, the Milky Way and Andromeda, are going to come together and carry out kind of a dance. As the two nuclei move around each other, and then through gravity, they will come together. The spiral arms get stretched out, and when they come together, they will form a different type of galaxy called a giant elliptical galaxy. So imagine you're on the surface of a planet, and you could look forward in time, you will see Andromeda coming towards us. There's going to be fireworks when the gas in these two galaxies produces a myriad of stars. And then in the future, the view from afar would be of a large elliptical galaxy. So in my penultimate piece, I'll be talking about galaxies far, far away.